Welcome everyone. I'm Ron Powell, the Editorial Director and Associate Publisher of the BI Network, part of TechTarget, and I'll be the moderator for this webcast. Today's webcast is part of a three-part series addressing the topic of integrating big data, sponsored by SyncSort and presented by industry expert and BI Network contributor Mike Ferguson. As many of you know, SyncSort is a leading provider of high-performance data integration solutions and the market leader in high-performance sort solutions for open systems and mainframe environments. With a 40-plus year track record of innovation, SyncSort has more than 15,000 deployments in organizations around the world. Our featured expert today is Mike Ferguson. Mike is Managing Director of Intelligent Business Strategies Limited. As an independent analyst and consultant, he specializes in business intelligence, data management, and enterprise business integration. He has more than 30 years of IT experience. He's a popular speaker at events all around the world and has written many articles for the BI Network and other publications. The third part of this webcast series, Mike will focus on Hadoop and big data integration. Mike?
Thank you, Ron, and hi, everybody. Welcome to this third part of the series. I'm going to focus on Hadoop. Okay, so if you've tuned into any of my first two webinars in this series, you will have seen me talk about the fact that the new data sources and new kinds of analytical workloads that we've created have resulted in a new extended analytical enterprise. That means that we have a new, more complex analytical environment which consists of multiple analytical data stores, some of which are the traditional ones, relational databases for traditional data warehousing and data mart usage. But we've seen that extended both on the support of complex analytics of structured data, which is through data warehouse appliances, and also through the emergence of analyzing unstructured data and more complex data types through Hadoop and other kinds of NoSQL analytical data stores. The example of the one shown here is a graph database. And in addition, more tools appearing on top of these, some of which are traditional BI tools, but also new tools emerging in order to analyze data on those platforms. In addition, we've got the greater pressure, if you like, on ETL processing because of the fact that we're supporting the supplying of data to multiple analytical data stores and in addition to mass data management. And also the movement of data between analytical data stores during analytical processing. And so much more pressure being placed on data integration technologies to support that, as well as, of course, many different new data sources and connectors. In the last session, we looked at the top 5 requirements there. If I focus on the left-hand side, looking at Hadoop, then Hadoop is not a database. It's a software stack. It's an open-source software stack with Apache, and it consists of a number of different components, including the Hadoop distributed file system, which allows you to break data up into pieces and distribute it across multiple nodes, if you like. And there could be thousands of those. It includes a programming framework, which is a style of programming called MapReduce programming, where I can build batch processing jobs to analyze large data sets that are distributed across multiple servers. And I can write those programs in a range of languages. So MapReduce is not a language. It's a style of programming. I can write those in languages such as R, or more likely Java or Python, which is what I see very regularly amongst my client base. And I can also make use of languages like Pig, as you can see on there, which is a data flow language, in order to create MapReduce programs to process data in HDFS systems. Also part of this stack are a couple of components which I'd like to point out. One is Hive, which is a data warehouse interface to the Hadoop environment that has a query language called HiveQL. It's like SQL. It's not a full subset of SQL, but it can take SQL queries in and convert those to MapReduce programs that it can run in batch on data stored in the HDFS file system or in the HBase database, which is a column-oriented store, which is part of the Hadoop stack. In addition, the other thing I'd like to point out there is Mahout, which is, of course, a library of analytics that I can make use of if I'm a developer or building MapReduce applications in order to analyze data in that environment. Now, today, Hadoop is not just an open source software stack. It's actually commercially made available by a range of different suppliers, which are on the screen now. So you can see some of those are well known, some of them perhaps less well known. Of course, all of them offering Hadoop either in Apache format with additional services around it, or in a modified Hadoop stack where they've tried to strengthen the Hadoop open source offering by adding more features for more robustness or whatever. But there's a range of different packaged Hadoop distribution offerings out there now that are available for customers in order to perhaps lower the risk and get pre-configured options available to them. Some of those come on their own hardware appliance in order to make it easier to roll in a pre-configured Hadoop cluster to get up and running with. So in terms of using Hadoop for analysis, there's, if you like, popular ways in which we're seeing that happen. The first way is to use it for exploratory or investigative analytics. And that's often being done by really advanced users, sometimes referred to these days as data scientists. These are often mathematically oriented people. They could be engineers in an oil and gas company, for example. They could be biochemists in a life sciences organization. They could be other kinds of power users. But the key point is that these people are often, the small number of people would often get together to do batch analysis on data that's not well understood, often data that's unmodeled. In a traditional data warehouse, we would create a data model and then we would put data into that data model. In a Hadoop environment, we don't know what the model is in many cases. And so we want to analyze that data in order to work out what's in there that would be of business value that we could extract out and put into a data model. And so therefore, we need more powerful analytical capabilities to be able to do that. And so we're not looking at hundreds or thousands of concurrent users here. We're looking at a small number of data scientists working on complex data types and unmodeled data in order to try and derive business value from it that may enrich what we already know. The second use of Hadoop, or major use of Hadoop, is acceleration of ETL processing in order to exploit the power of a cluster of hundreds or maybe even thousands of servers in order to process very large volumes of data, which could be structured data. There's no reason why you can't put structured data in a Hadoop environment. But it's more likely to be multi-structured data, semi-structured sources like email, for example, or XML, or unstructured sources like text or even video could be loaded up. It's particularly well suited to large data volumes. And in order to do this batch analysis, we have this MapReduce style of programming that has emerged in order to exploit the full power of massively parallel computing in order to apply all of that resource to an analytical problem. And so what you see from this chart is the way in which MapReduce applications work. Effectively, there are two kinds of processing. There's the map processing and the reduce processing. I like to think of it a little bit like map is a bit like ETL and reduce is a little bit like producing BI from that data. But the key point here is that it's a style of processing that's designed to exploit parallelism, so where every part of that application is running in parallel in the main. And it's not the case that programmers have to know that. They can write their applications and compile them, and they will run in parallel on this Hadoop cluster, potentially exploiting the power of thousands of underlying servers in order to apply compute power to a big data problem. And so what we're seeing in the use of Hadoop then is first option would be data scientists coming together on a Hadoop environment and creating exploratory or investigative environments, which are sometimes referred to as sandboxes. And so they load data up into those sandbox environments in order to be able to do various kinds of batch analytical processing on that data to produce some kind of business insight. And those batch analyses will run in a MapReduce programs. Okay, and so once we bring data into the Hadoop environment, we can do analysis on that data in a number of ways. First of all is we can write our own custom MapReduce programs with custom analytics, or we can develop MapReduce programs with pre-built analytics. For example, the Hadoop Mahout library that I spoke about earlier, which comes with a whole library of different analytics that I can apply to the data in order to be able to derive value from it. Or in addition, we could have third-party analytical offerings, which different suppliers are also offering on top of a Hadoop platform, perhaps for specific kinds of analytical problems in order to provide insight in a pre-built packaged way. So very central to Hadoop analytics is the use of the Mahout library. And what you see here from this slide is the different categories, if you like, of analytics that are available out of the box with Hadoop Mahout. And clearly, you know, data scientists would like to exploit those different kinds of analytical techniques in order to analyze the different kinds of data that they're looking at, and in order to do various different kinds of statistical analysis on that. So this is the kind of library that's really designed for someone who's trained in understanding what these different techniques are in order to exploit them to the full. The data scientists are often a very advanced kind of user with a very strong mathematical background that would be able to take full advantage of those pre-built analytical techniques. So looking at ETL processing in the context of sandboxes and data science kind of exploratory analytical projects, ETL processing can take advantage and run in two ways. For this kind of environment, we would pull data, from various data sources, whether those are unstructured data types, multi-structured data sources, inside or outside the enterprise. We'd load that data in, discover what data that and do discovery on that data, try and parse and transform and clean some of that data to make it available to data scientists in a sandbox. And they would then do custom-based analytics on that using MapReduce programs and perhaps the Hadoop library, some of those analytical techniques there, and produce business insights. So you can see on the right-hand side of the chart here that ETL processing is supplying data into that sandbox environment for those kinds of projects with a small number of very highly sophisticated business users. And once we derive insight from that data, ETL processing gets involved again in extracting data out of that sandbox environment and into more traditional data warehousing environments to enrich the data that we already have there in order to give us deeper insights. So it might be that we're analyzing review websites in order to understand customer sentiment that's recorded in HTML text format. So we just want to pull that data in, start to try and derive sentiment out of it, and then from what we know, we could add that information into that data warehousing environment in order to enrich what we already know. In order to speed that processing up, we can speed up ETL processing not only from a development perspective but also from an execution perspective. One way in which we can do that is to try to optimize ETL processing by using a library of MapReduce functions that we could take advantage of that are already written. So we can write our own MapReduce ETL jobs, include those pre-built functions in order to build our MapReduce jobs ETL jobs more rapidly, and then deploy those MapReduce ETL jobs to bring that data in and process it and make it available in that sandbox environment. So that speeds up the overall development on a Hadoop environment by using this kind of pre-built library approach of transformations. So that would apply, for example, to structured and also semi-structured data, but we also need to take care of the unstructured side, whether that's news feeds or whether it's social media coming in. We need to do perhaps text analytics and process that kind of data to bring it on board. Both of those kinds of data types, unstructured data sources and semi-structured data sources, could come into a data science kind of environment. The other major type of processing going on in Hadoop that I talked about earlier is this whole idea of using Hadoop as an ETL accelerator. And this slide kind of tries to simplify why that's become a very attractive pattern for a lot of organizations. What you can see here is the fact that data is coming out of organizations faster than they can consume it. And so there's a need to be able to speed up the consumption of data, both coming from outside the enterprise or potentially even from inside the enterprise, customer interaction data, or even data in content management systems or archive data sources, where you want to blow the dust off of those tapes and bring that data back in again and start to consume it and analyze it to see if you can derive more value. I can think of one example of an insurance organization who wanted to take a lot of documents that came in from brokers, which were in just office document format, and they just wanted to be able to put all of those documents into an analytical environment and derive structure out of it in order to enrich what they already knew. So this idea of creating an enterprise data filter to rapidly consume data to bring into the enterprise is getting a lot of attention right now. But in order to do that, we need to really extend what ETL can do by giving it the ability to also analyze as well as do traditional extractions, loading, parsing, transformation of data. And so what you see here is on the right-hand side of this diagram, the green arrow going all the way up through analytics. And so effectively, and on the left-hand side, the data management tools effectively spanning Hadoop, that is to take data into Hadoop environment, continue processing while you're in the Hadoop environment, and carry on taking data out of the Hadoop environment into other data stores, whether that be traditional data warehouses or even other NoSQL data stores. We're seeing a lot of activity going on here, and I would expect that much more to happen in the next 6 to 12 months in order to automate and embed analytics inside of ETL workflows. Of course, that allows us to more rapidly consume data that is perhaps less well understood or unmodeled, and then derive insight of business value, and then bring that in for further analysis in more traditional environments. So one side of it is very much a sandbox, exploratory use of Hadoop with a small number of very advanced users. And the second approach is very much a consumption of additional data that's needed by the business in order to improve its competitive advantage. And so what you can see from this chart is the ability to consume or leverage Hadoop to accelerate data integration by pulling in massive volumes of data, which could come from inside or outside the enterprise, and provide that insight into data warehouses and join it up with traditional structured data coming from our own operational transaction processing systems into a data warehousing environment. It's also the case that we may not move that data to a data warehouse. We may move that data post-Hadoop processing into another NoSQL database. So a good example here might be Twitter data. So what you're seeing with this slide is one of my tweets. It's a Follow Friday tweet where you can see a whole bunch of Twitter handles right there. So not only is this 140 characters of text, which would need to be potentially parsed, and if there was other just text in there, I could, it might be sentiment that I may want to analyze. But you can see also within this 140 characters of text, there are Twitter handles. And I may want to extract those Twitter handles out because that tells me about a social graph. And I may then want to move those Twitter handles into a database that's more optimized for graph analysis. And so, again, you see the use of ETL processing in order to move data between analytical data stores. first phase of analysis was to analyze the unstructured data. The second phase of analysis was to analyze a social graph that came out of the first phase of analysis. And so what we're seeing here is the use of data integration to move data between analytical data stores during analytical processing. So we're not done by the time we get through Hadoop. We're moving that data, in this case, to a graph database. And so what we're seeing is several steps are involved in analyzing data in order to provide answers to what the business questions may be. So in that case, there's no question that it's not just using Hadoop and data integration to load it up or even to analyze data in Hadoop. It's also to move it between systems once I've finished the Hadoop processing, Hadoop analytical processing that's needed. But of course, Hadoop itself isn't a panacea. There's a lot of hype out there about this technology. There's no question that it's absolutely being taken on board by large enterprises. But as with any technology, there are strengths and weaknesses. And so there are cases where certain kinds of processing don't perform as fast as you would like. And it's also the case that multi-structured data, is pretty tough to analyze. And so there's no question that analytical processing is going on in other data stores, and there's no question that there's opportunity to help performance, improve performance in a Hadoop environment. And one of the ways in which you could potentially do that is to look at ETL optimization technology from third-party or vendors such as SyncSort. So these two slides are from our sponsor today, which shows how you could extract data from a range of different data sources, how you could then accelerate or optimize ETL processing by using a range of different transforms, and then load that data into Hadoop environment, and therefore pre-process the data and compress the data using SyncSort DM Express. And then the second of these two slides from our sponsor that I chose to include in my presentation today is really the use of DM Express to optimize Hadoop processing itself. And so what's happening here is, there's additional transforms that allow a MapReduce application in order to invoke massively parallel transformations from inside of an ETL MapReduce job. So in that case, DM Express is not generating MapReduce code. In this particular case, DM Express runs native on every data node on a Hadoop cluster, and therefore a MapReduce application can call the appropriate transforms to run in parallel during a MapReduce program execution by calling these high-performance transformations whilst the MapReduce programs are executing. So all of that can help accelerate ETL processing, whether that's ETL processing to load sandboxes, or whether that's ETL processing in the form of this data filter that I talked about in order to bring data in and process it more rapidly and automatically analyze it. So to conclude then, there's no question that data integration has a much bigger role to play in this extended analytical environment. We're seeing a lot of activity going on to add additional functionality in data integration to increase support for this Hadoop environment. No question that ETL workloads are going to increase considerably as organizations adopt big data analytical platforms, whether that's Hadoop itself or whether it's another NoSQL database, or whether it's data warehouse appliance, or whether it's stream processing or real-time analytics, or all of those. And because of that extended analytical environment, the challenge is now to be able to manage that whole ecosystem. And ETL has a much more prominent role in managing data across that ecosystem, both in supplying data and in moving data between analytical data stores during analysis. Volumes, no question, are increasing rapidly, and particular things like semi-structured, unstructured data or sensor data will drive volumes to new levels that most organizations may not have experienced before. And that's going to challenge ETL scalability. And so we really need to not only be able to analyze the data, but we've got to be able to scale ETL processing as well as scale the analysis of the data. And I think what many organizations are looking for is to potentially use Hadoop to improve the performance of ETL processing, as well as to use it as a platform for exploratory analytics. And I think that's a pattern I see a lot of from my clients. So I think what we're seeing, therefore, is customers wanting to look for extensions in their data management tools to support new data sources, to support new analytical platforms, so that they can be able to manage data across this extended environment. But there's no question that this is still a young industry. It's still a young, emerging space, and I would expect a lot more to come. So be prepared for change. But it's an exciting time. There's a lot going on, and no question these new technologies can help organizations solve analytical problems that they just couldn't solve before. Okay, so with that, I'd like to thank you for attending the last of my 3 sessions, and I'd like to hand back to Ron.
Mike, as you noted at the end of your presentation, Hadoop is still an emerging technology, and the landscape is constantly changing. Where do you see Hadoop going in the next 3 to 5 years?
That's a great question. Big debate, big debate. For me, there's no question that it's going to become very much part of the analytical landscape. I think it's going to be, as we already said, part of an extended analytical environment. And I suppose, therefore, Hadoop, for me, is going to be a component in a bigger analytical ecosystem. And so additional things will happen around it as well as on it. I think around it we're going to see new technology to manage multiple analytical data stores, of which Hadoop is one. I think in addition we're going to see the ability to simplify access. You know, you have to look at this from an end user perspective as well. You know, now we've got to access multiple analytical data stores, which as far as an end user is concerned means complexity. They don't want to have to worry about where's the data. They just want to ask the question. And so I think what we're going to see is gradual hiding of complexity. That is to say, from an end user tool perspective, you know, we're going to see the ability to ask questions from an analytical ecosystem, and something is going to decide where should that analytical workload run. Should it run on Hadoop? Should it run on a data warehouse appliance? Should it run on a data warehouse? Should it run on a NoSQL database like a graph database? Or should it run on some combination of those? And so for me, you know, there's a question, you know, would, you know, we saw object-oriented databases being consumed by relational with the introduction of user-defined data types. We've seen XML databases consumed by relational. There's a big debate out there right now as whether or not Hadoop could be consumed by relational. That doesn't necessarily mean that Hadoop has to support SQL. We already know that Hive can handle SQL input and convert it to MapReduce. But what's more interesting to me is the emergence of external table functions in relational databases. That means I can continue accessing relational databases and call functions that will go off and access Hadoop in the background. And so it's a very open area. Are we going to see the exploitation of multiple analytical platforms with ETL workflow? No question. Are we going to see Hadoop consume relational? That's a more difficult question to answer. Possibly, but no doubt about it that complexity will be gradually hidden, and I think we'll start to see the emergence of a new, more grown-up analytical environment that consists of multiple analytical data stores, but as far as the business user is concerned, they don't need to know about it.
Well, Mike, great insight. Thank you so much for your presentation. And I'd also like to thank SyncSort for being our sponsor. SyncSort's DM Express solutions enable organizations to maximize the value of big data through the application of fast, efficient, simple, and cost-effective data integration technology. DM Express is used to integrate, optimize, and migrate data in a variety of use cases, including high-performance ETL, as Mike has showed earlier, and Hadoop optimization. Viewers can learn more about SyncSort solutions for big data by visiting syncsort.com/DMExpress. Be sure to watch the other two webcasts in this series, and I would like to thank all of you for attending today. Thank you.